Okay, in 10.2 we've got a group of 200 tourists and they're visiting a restaurant and they have two choices. They can get chicken or beef. Clearly there's no vegetarians here. The manager observed that 35% of tourists chose beef on the first evening and 70% of the tourists chose chicken on the second evening. And now we need to draw a tree diagram showing the different possibilities for the 2 evenings, and we've also got to get the associated outcomes. So let's start drawing the outcomes for the first evening. So on the first evening, I can make one of two choices. I can choose beef or I can choose chicken. And we've got to get the probabilities associated with that. And on the first evening, 35% of the tourists chose beef. Now I don't want to put percentages on my tree diagram. I'd rather work with decimals or fractions. I find decimals are a little bit easier to work with. It makes the mental maths a bit less exhausting. So this can go straight in the calculator, or if you're strong enough you can do it mentally. It's going to be 0.35. And then on the calculator you just put 35%, press equals, and you get that 0.35 that I was talking about. So that's going to go on top of this branch. And now we use the complement rule to get this. If 35% of tourists chose beef here, the rest of them had to have chosen chicken. So this one is going to be 1 minus this number, which is 0.65. And just to be overly cautious, I like to check it with my calculator, and it does indeed give me that 0.65. So that sorts out evening 1. Okay, now on the second evening, they've got the same choice. They can either choose beef or chicken. So we're going to have another choice tree after the beef, and we're going to have another little choice branch after the chicken. And then that pretty much captures all of the possible choices I can make. I can choose like beef, I can choose beef chicken, I can choose chicken beef, or I can choose chicken on the different evenings. And now we've got to put the probabilities on these branches. So 70% of the tourists chose chicken on the second evening. So these chicken branches are going to be 70% or 0.70. And then we use the complement rule to find the probability of the beef branch. So 1 minus 0.7 will give me 0.3, and it's going to be identical over there, also 0.3. And now there's one last thing left to do. We need to state the possible outcomes of the choices. So how we do that, this branch that goes here, we just listed as BB, beef. I chose beef on the first evening and beef on the second evening. And then for the second branch, that's going to be beef chicken. It has to be in the right order. So this one's going to be BC, which is short for beef chicken. Okay, if we follow this branch, we're going to get chicken beef over here. And this last branch will give us chicken. That would be my personal choice. And now we are officially done with the tree diagram. So my first mark comes from the correct sort of first choice I can make. The second mark comes from the correct second choice I can make with the associated probabilities. And the third mark comes from the correct outcomes being stated at the end of your probability tree. Now we need to calculate the number of tourists who chose the same meals on both evenings. So I'm going to get a percentage of the tourists, and then once I get that percentage, I'm going to multiply it by the 200 people to find out the number of tourists. So to get the percentage of people who chose the same meal on both evenings, I've got to follow this branch, beef, and I've got to follow this branch, chicken. And then to start this off, I'm going to say P equals, the probability equals. And if I go down this branch, I've got to multiply these two numbers. So it's going to be this one times this one. Okay, so that sorts out my beef outcome. Now I'm going to add the next branch to that. The next branch, if I'm going down this branch, I'll multiply these two numbers. So it's going to be 0.65 times 0.7. Again, there's no ways I'm doing that mentally. That's going straight on my calculator. So if I just pop that in the calculator, press equals, and then insert decimal, it gives me 0.56. Another logical way to see the 0.56 is you can see it as 56% of people chose the same meal on both evenings. Now, if I want to get the number of tourists, I'm going to say 0.56 or 56% times the total number of tourists, which is 200. Just going to pop that in the calculator, press equals, and it tells me 112 people chose the same meal on both evenings. And then for one last time, let's have a look where the marks are coming from. The first mark comes from showing how you used, basically how you multiplied and added your probability branches together. The second mark comes from the 0.56. And the last mark comes from the 112 tourists that chose the same meal on both evenings.